This is for Year 10 Methods Pathways. We're going to look at exercise 3.5. So it's the second exercise in the worksheet. We're going to look at theorems 1 and 2. Okay, so let's look at the key ideas. The angle AOB, so AOB is here. So we're talking about this angle here. We know that the angle AOB is subtended by the minor arc. So the minor arc is referring to this this length over here. We know the angle covering that is over here, which is AOB. So this is the angle here. Okay, that's the angle, and it's covered by that arc. Now this minor arc is at the center of the circle, meaning it's stopping at O. Okay, stopping at the center of the circle. Whereas we can see here the arc AB is subtended by the angle ACB. However, the angle is on the outside of the circle. Okay, so that's really important. Okay, there's a relationship between arcs subtended to the center of the circle by angles in the center of the circle and by the angle outside of the circle. Okay, so the relationship is this. If you can identify the arc, so this is the arc here, if the angle subtended is inside the circle, so not inside the circle, I mean the center of the circle, compared to the angle subtended outside the circle, here, there's a relationship. The relationship is if they're covered by the same arc, the angle that goes to the center is double that of the angle that goes to the outside. So I'll go through a very, very simple example. If I draw a circle there, and we have an arc, so this happens to be a minor arc, and we have an angle of, let's just say that's 30 degrees. If I have an arc going to the outside of the circle, so as you can see, both are covered by the same arc, then this will be 15 degrees. Oops, that will be 15 degrees because it will be half of what the one going to the center is. Okay, so here's some examples. Can you see we've got arc AB? Okay, we've got arc AB here. We've got arc AB here. The arc going to the center and the arc going to the outside. Okay, it's both covered by the same arc. However, the arc in the center is double that of the arc going to the outside. So in example 1, if it's 140 to the center, then it must be 70 to the outside. Okay. Another example is that the arc AB, this happens to be it's not a minor arc, it's a major arc, and you can have major arcs, that's fine. So if it's covered by this arc, that's fine. So you can have minor arcs and major arcs. We can see that this is 210 over here, and it's going to the center. Okay, we can see it's going to the center point here. Then the arc going to the outside, it's covered by the same arc. Okay, can you see the red line? It's covered by the same arc. Then it's half of what it is to the center. So half of 210 is 105. Similar here, this is my arc. The arc's going to the center. If that's 96 degrees, then the arc going to the outside, okay, it's covered by the same arc, it's going to the outside of the circle, so it's going to a point outside the circle, is 96 degrees. So you can see that the one going to the center is double the one going to the outside. So based on this principle, I can draw many arcs. Okay, I can draw an arc that's covered by AB. That's still 48. I can draw another arc like that. That's still going to be 48. I can draw another arc like that. That's still going to be 48, etc., etc. Okay. Theorem 2 is a special case. I have an arc AB. It happens to cover half of the circumference of the circle. Okay, that's still an arc, but it happens to be a flat arc. Okay, I mean the angle happens to be a straight angle. Okay, so the angle covering this arc, or subtended by this arc, would be 180 degrees. This is going to the center. Okay, so it's going to the center here. And the same arc going to the outside, so going to the outside, will be half of it. Okay, so if this is 180 degrees for the arc going to the center, then the arc going to the outside would be half of 180, which is 90 degrees. Okay, so that's a special case. Okay, you're applying the same theory as theory 1, it just happens to be a special case. So, for example 8, it says name the angle that's subtended by the same arc as ABC. So, ABC, can we see that we're referring to this arc here? Okay, so ABC, that's one arc that's covered by the arc AC. Another arc that's covered by AC would be this arc, okay, ADC. Okay, so ADC and ABC are covered by the same arc, which is here. Okay, or should do a different color. It's covered by the same arc here. So this would be the arc of interest. Do a different color. This will be the arc of interest. Okay. Similarly, we're interested in arc CA. Which angles are covered by that? So we can see that CDA and CBA are covered by that same arc. Okay. So examples are shown here. I will do some quick questions in terms of values. So example 9 shows you some examples. So the arc of interest here is BC. The angle going to the center is 126. So the angle going to the outside must be half of that. So half of 126 would be 63 degrees. So A must be 63 degrees. Okay. Similarly, we've got an arc here, AC. We've got two angles that are subtended. The one going to the center. So one going to the center here. Okay, that happens to be 180 degrees because it's a straight line. And one going to the outside. So one going to the center, one going to the outside. The outside must be 90 degrees. 90 degrees. 90 degrees. So for exercise 3E, we want to name the angle subtended by the same arc as ABC. Okay, so ABC, okay, it's subtended by this arc. Okay, so it's covered by this arc. What's the other one that's covered by that arc? So there'll be ADC, okay, because that's the arc of interest. This angle is covered by that arc. This angle is also covered by that arc. Similarly, for the arc AC, ABC is covered by this arc. The angle ABC is covered by this arc. Also, ADC is covered by the same arc. For C, same thing. So I want to cover this arc. So the angle CBA is covered by that arc, and similarly the angle ADC is covered by that arc. Okay. For C, this one's a bit more complicated. We can see that there's a few that's covered by that arc. So we've got AEC, ABC, and I think there's only two. One, two. 1, I have to look at it this way, 1, 2, I think there's only 2, okay. Unless you can see another one. So the rest of them is just finding the unknown number. So for something like this, the arc is here. So going to the middle is double that of that going to the outside. So that x must be 40, okay? Because the one going to the outside is smaller than the middle one. For this one, we can see that we've got the arc here. So the arc going to the middle and the arc going to the outside. The outside happens to be outside point here, and this is the middle here. That must be double what that is. So if that's 40, that must be 80. We'll go through a more tricky one. This is the arc here. Okay, it happens to be a major arc. Okay, so the angle covered here to the center, and the angle covered to the outside. So the center angle must be double what 125 is. Okay, the center arc must be 250 degrees. Okay, so that must be 250 degrees. Okay, so the rest, and this is a right angle case, so if that's the arc, then the angle covered here is 180, so that's 180 here, and the arc going to the outside, okay, outside point here, must be 90 degrees, so that must be 90. So you can use the idea that angles inside a triangle must add up to 180 to work out that out. Okay, and there are some questions where you have to use the idea that that's the radius. Okay, so just be wary of that. So I'll go through these next in more detail next week, but you can basically figure out the theorem. So theorem 3, very quickly, any arc that both goes to the outside will be the same. Okay, that's what this theorem's talking about. Okay, which makes sense. So if you have an arc and two angles that go to the outside, they're always going to be the same. And similarly, if you have a quadrilateral inscribed into a sphere, so touching all 4 points touching the circumference of the circle, then we know that A and B add up to 180, and B and D add up to 180. So opposites of a quadrilateral add up to 180. So you can read the examples. So hopefully that get you started on the exercise.